Good morning, everyone. Welcome to ProMat 2023 in the Robotics and Automation Theater, sponsored by DC Velocity Magazine. Right now, we're going to be focusing on our next speaker, which is Michael Conlan from KNAPP, focusing on robotics, application, and technologies. So please give a warm welcome to Michael Conlan. Thank you.
All right. Let's get this started. So I'm Michael Conlan, robotic consultant for KNAPP Industries. So welcome to ProMat, and thank you for joining me here today on the Robotic and Automation Theater sponsored by DC Velocity. Today, let me stay with my... So today I'm going to talk about the rise of robotics, things to consider when evaluating robotics for your operations, and review some cool use cases for robotics and material handling. According to Gartner, by 2026, less than 3 years from now, over 75% of large enterprises will have adopted some form of smart robots in their warehouse operations. The term robot means different things to different people, but essentially a robot is an autonomous machine that can sense its environment, carry out computations to make decisions, and perform actions automatically and rapidly. This really covers a huge range of technologies and a large budget and performance range. According to the McKinsey & Company, the average share of investment in automation by sector over the next 5 years will increase substantially versus the previous 5 years, something I'm sure you guys all know as well. And the size of those investments is trending higher for robotics and automation. Some of the key influences contributing to the rise of robotics are that customers are demanding immediacy. Labor scarcity and labor productivity issues are going on still. Financial entry points are allowing for more rapid validation. Off-the-shelf solutions are becoming more and more dynamic, and scalability is possible through reduced lead times. So also technology enablers are converging, which is contributing to the rise of robotics as well, in the areas of better hardware, improved safety systems, vision systems, as well as control systems and actuators, standardized interfaces, cloud-based computations and storage, machine learning, and shared neural networks. This includes the use of sensors, cameras, and other types of perception technology. According to Peerless Research Group, the main area of focus for employing robotics or automation include increased flow and throughput, addressing labor constraints and labor costs, improving labor productivity, and improving safety throughout, just to name a few, and you can see the rest of them as well. Some of the key use cases for robotics today are in the area of palletation or depalletizing, packaging, transport within a facility, goods receiving, storage and picking, sorting, and pallet movement. According to McKinsey as well, piece-picking robots, which you'll see a lot of them here today, and mobile robotics are emerging as a new important category of growth with upwards of 45% by 2027, especially in the micro-fulfillment space. So getting robots right. There's a wide variety of robots used in material handling today, each with its own unique features and capabilities, including mobile robotics, robotic arms, cobots, shuttle and cube system robots, with, of course, decisions around timelines, the amount of collaboration you're looking for, performance, scalability, redundancy, and, of course, the return on your investment. So getting robots right. Implementing new technologies and equipment in material handling require proper research, planning, testing, training, and monitoring to ensure successful implementation. Some of the key areas and the key questions you should be asking yourself. What are you trying to do? Are you alleviating labor pains, accelerating throughput, increasing storage capacity, improving employee or customer experiences, doing more in the same space, enabling more sustainable operations. Also, what will drive your decisions? Is it cost, lead time, cubic utilization, throughput? And the prioritization of these ensure that you make the best decision based on your business drivers. And don't just buy a robot. Buy a system and the organization that backs it. Investing in robotics shouldn't be transactional. It should represent the beginning of a mutually beneficial relationship and a partner to help your business to automate your processes, improve your supply chain and logistics, optimize your operations, and gain valuable insight through data analysis. Truly a partner who can understand the unique needs and challenges of the industry in which you operate. And then, of course, you also want to look at your long-range goals. Do you ultimately want to achieve a full supply chain anatomy, build resilience, or create an exceptional customer experience? It's up to you. So how'd they get so smart? You can't talk about robotics without talking about software. Robots are only as good as the software that drives them. Software makes the robots more intelligent, adaptable, and capable of providing competitive advantage. Autonomous robotics for distribution and fulfillment require three types of main software. Intelligent logistics softwares for dynamic orchestration of complex distribution and fulfillment processes. An automation data system for automating the collection, distribution, and maintenance of item attributes required for high-performance robotics. And also a universal AI platform that enables robots to see, think, act, learn, so they can pick up virtually any SKU or item, regardless of the shape, size, or packaging, and share those learnings with other connected robots. Artificial intelligence is being used to make material handling operations efficient and more adaptable. The industry artificial intelligence technologies such as machine learning, computer vision, natural language processors like ChatGPT are being used to enhance industrial operations and manufacturing processes. And of course, they're being used in a wide range of industries: automotive, electronics, aerospace, and healthcare, to optimize production yields, reduce costs, enhance safety levels, and boost profitability. And of course, just as we spoke about, data drives performance. It turns out that robots need a lot of data to function efficiently. To achieve the best possible performance, every robotic application requires data. Unfortunately, today's master data wasn't designed for robotics. It doesn't include things like weight, dimensions, packaging type, contents, center of gravity, tilting, stacking, or picking behavior, and much more. Manually recording all this data takes time and money, and the quality of the data may suffer. You have to look at them, measure the dimensions, and enter all the data and check it twice to make sure everything's correct. It's just not an efficient process. So some of the things that supply chain leaders are doing for successful implementation of robotics and automation in their systems. Basically, they've included things such as deploying autonomous robotics for core logistic processes, including storage and retrieval, conveying and sorting, picking, packing, and palletizing. Also focusing on lower touches throughout their operation. So they're using automation and robotics to really improve their processes. Expanding master data to include automation data, and incorporating modulable and scalable elements for automation solutions, and also adopting all-in-one solutions that pack a lot of functionality in one single system. Supply chain managers are faced with competing priorities. It's the era of supply chain sustainability, modularity, agility, resiliency, autonomous decision-making, and more. It's the era of everything, everywhere, all at once. Today's supply chains weren't designed for this kind of epic upheaval. Reinvention is essential and inevitable. To do this, the vast majority of supply chain leaders are looking to robotics and automation to accelerate throughput, alleviate labor challenges, maximize space utilization, improve worker conditions, and automate their processes throughout. They are doing this by employing goods-to-person systems, robotic storage and retrieval systems, autonomous mobile robots, articulated robotic arms, automated dispensing, and robot fulfillment systems, among other technologies. So here's a good use case that I want to take you guys through. The world's largest retailer had one primary goal when building its next generation fulfillment network: show online customers that they need to look no further to get what they need when and where they need it. In addition to fulfilling orders fast, the retailer wanted to create a positive workplace that would attract and retain employees. They also wanted to maximize every square inch of their new fulfillment centers. I'll go through this, let you guys see a quick video on the process. So yeah, and the result, they were able to improve storage capacity, increase order fulfillment, reduce touches, and created a better work environment for their employees. The core component of this high-tech fulfillment center is a robotic shuttle system, which you saw in the video. The robotic shuttle system significantly streamlined the fulfillment processes because it packs a lot of functionality in one system. It automatically stores, it picks orders, it buffers goods, sequences orders, supplies good-to-person workstations, and replenishes other work areas. So now, instead of a 12-step process, they now have an automated 5-step process. So a different use case is a national grocer was among one of the first to pilot automated micro-fulfillment centers. The grocery chain deployed its first micro-fulfillment center in 2019 and opened up 7 new facilities in 2021. Today, curbside service is the fastest growing component of their business. The micro-fulfillment center pioneer has continued to evolve their micro-fulfillment centers to improve economics of online order fulfillment, combat ongoing labor shortages and rising labor costs, and support e-commerce growth without expanding their footprint. The chain believes that e-grocery will eventually comprise 20% of their business. To increase speed and accuracy without increasing space requirements, the grocer is deploying next-generation micro-fulfillment technology. The next-generation micro-fulfillment technologies and footprint are smaller, faster, easier to construct and install. They even increase storage capacity. Next-gen MFCs also include autonomous mobile robots. These open shuttles roll independently within the micro-fulfillment center and are completely safe for use around people. Which is just a little bit more into the AMRs. The AMRs easily integrate into existing robotic shuttle systems. Goods are stored in a robotic shuttle system, like I showed you before, and pick good-to-person workstations. Completed orders are transported by the AMRs to the flow rack and assigned to a buffer conveyor. The flexible transport system requires very little space. Another use case, retail pharmacies are in dire need of major transformations. Pharmacies are understaffed, pharmacists are overworked. During the pandemic, pharmacists took on a greater role in patient care, providing testing and vaccination to hundreds of millions of people. An in-store robotic picking system located at one of the pharmacies operates in a hub-and-spoke configuration to serve the other 3 pharmacies. It can easily scale to support up to 12 pharmacies located within a half-hour range of each other. Virtually everything is fully automated: labeling, vial verification, dispensing, capping, sorting, packing, and tracking. Orders are consolidated by store, so the same courier handles store replenishment and home deliveries. With this system, the pharmacies were able to offer no-wait and drive-through pickups, personalized pill packs, self-service kiosks, free local delivery, and around-the-clock dispensing and medications and over-the-counter products. So as Gartner mentions, the use of robotics in material handling has significantly grown in the recent years and expected to continue to grow in the future. Material handling industry is constantly evolving with new types of robots and technologies being developed all the time. So thank you for your time, and I'll open you up for any questions. And of course, please stop by our booth if you want to learn more about the growing world of robotics.
Hello? Any questions? Here we go.
Hi, good morning. Can you talk a little bit about use case stories in retail distribution for perishable goods?
Say that again.
Can you talk a little bit more about use case stories for retail distribution for cold chain for
Yeah, and that's a good question. So the question was about the cold chain and developing technologies to function within the cold chain?
Yeah, we delivered it to locations.
Yep. And a lot of that is happening in the micro-fulfillment space with groceries as well. But it is a growing area of robotics because most robotics are not geared for frozen applications. So there is development going on in that area. And there are some suppliers out there today who are in that space providing automation for freezers and refrigeration as well. We do as well, yeah. We've got several programs going on right now. So.
I'm curious, how small is too small to automate in terms of business size?
How smart is too smart?
How small is too small to automate for a business size?
Yes, that's a good question.
What's the threshold?
Yes, and that's where most of the folks who are here in the show today are looking for the mid-size to the smaller applications. That's really where the growth is going to be because a lot of the majors are already autonomized and robotic throughout their facilities, and now they're enhancing those. But yes, and really it gets down to you, the customer, and your use case and what you're willing to do. One of the things KNAPP has been successful with is being able to scale with our customers. A lot of times with these mobile robotics, people go, wow, looks cool, the business case is there, I'm not so sure. So we're doing testing and we'll do trials. You hear of robot as a service, that's being used as well. Leases are going on, but you really have a lot of folks like yourself say, hey, prove it. Show me that it works. Show me that I get the money that I think I'm going to get out of that. And that's the other thing that's going on. For an ROI, it used to be how many people can I eliminate? How much money can I save in labor? That conversation's not happening as much. It's more about how do I get a consistent production? How do I get a consistent throughput? What can I do to keep this thing running? So, and can I use my labor elsewhere in the facility instead of doing redundant tasks? So that's a key motivator for folks getting into robotics. I don't know if that answered your question, but yeah. Thank you.
So I've actually got the opposite question that he had, because I'm looking to automate heavy manufacturing, so large, heavy items that are of odd shapes and sizes. Any experience with that?
Yes, and that's where a lot of folks are going as well. So we have different palletization and depal technologies for mixed case. We also have new AMRs. You'll see a lot of AMRs out here, autonomous mobile robots for forklifts. And just for transferring and moving heavy stuff throughout the facilities. You're seeing large ASRS systems, and they're here today. Stove's got one as well, for pallet movement within a facility. Those are being commingled with the unit delivery as well, to where you're getting a full service. Hey, I can supply my B2B, I can supply to the e-com, and directly to the consumer.
Anyone else? All right, thank you so much,
Awesome.
Michael.
Thank you. Thanks for coming.